Welcome to our 2025 end of season event. I'm Shannon Bolt. For those of you who don't already know me, I'm the program coordinator for the Salish Sea Guillemot Network Pigeon Guillemot Breeding Survey. And we have lots of folks joining us this evening from all over the Salish Sea. I see lots of familiar faces and names. We have surveyors from all 7 of our regions. I see folks from Clallam County here and Jefferson County, Camino, Whidbey, Bainbridge, and Vashon Islands. And the South Sounders are here as well. I'm included in that group. And I think we may also have some spouses joining us and some tribal representatives and members of Whidbey Audubon and other sponsor groups. So all of you who love the Guillemots and care about our beautiful Salish Sea. So thank you all for taking the time to join us this evening and celebrate another successful Guillemot breeding season. I'm also excited to be here this evening to get our 2025 data summary, and of course to hear from our special guest speakers, Erin Arzola-Davis and Dr. Sarah Converse. So we'll start with the land acknowledgement. As a group, we recognize that we are residing on the ancestral lands of the Coast Salish people. These tribes have lived on and cared for the land and water since time immemorial. We respect and honor all Indigenous people, and we acknowledge our responsibility to learn the truth about history, support tribal sovereignty and livelihoods, and take action towards inclusion, partnership, uplifting Native communities, and continuing their legacy of stewardship. All right, and before we dive into the main program, I do have a couple of brief announcements. A few folks asked me to share an update on a data request that we got from the Navy with the group. So I'm just going to keep it really high level. I don't have any fancy graphs to show you guys tonight because the report is not final. But for those that don't know, the Navy did request some of our data to use to assess potential noise impacts to the Pigeon Guillemot colonies on Whidbey Island due to increased growler jet activity on the island. So they came to us and we had the data to give them. They were looking for trends related to breeding success. So looking at average number of chick burrows per colony and how that might change over the years, duration of prey deliveries, and fledging success. So that would be assessed by how many weeks or burrows that had a minimum number of weeks of prey deliveries. So they did use data from Whidbey, the Whidbey region, and also South Sound from 2013 to 2024. And what I can tell you is that we have good news. They could not find any negative trends in breeding success that could be correlated to growler jet noise. And you may be wondering, did they do the analyses correctly? And they did work very closely with Dave and I on these analyses. They really wanted to make sure that they did this thoughtfully. And so we feel fairly confident that they did do this properly. And we weren't terribly surprised because we know our guillemots are pretty adaptable to humans being around and the things that come with humans. So the takeaway here, though, that I really wanted to share with everyone is just how valuable this survey is and to have all of this long-term data. And that is largely due to you all. And so I just wanted to, tell everybody, pat yourself on the back. It's pretty amazing and incredible that we had enough data to give them that they were able to look at these trends. And it's really a testament to all of the effort put in by all of you guys over the years. So big kudos to you. And that's a proud moment for our survey. And this will open the doors in the future as well for us to provide data when we're looking at impacts to any environmental changes. So. All right, and before we move on, I also want to be sure to thank our sponsors and our partners. We really couldn't do this without the support of all of these different groups. Each region is coordinated and sponsored independently. And so all of the groups that you see here have been very active in supporting our survey. So I just want to thank the sponsors and partners as well, in addition to all of the volunteers who have worked on this project for many years. And then Govinda is going to share with us really quickly. She has written a book that will be launching soon. So Govinda, do you want to tell us a little bit about your book?
Absolutely. Hi, everyone. So after maybe 3 years or so, we have a book that's finally in print, and I have a copy right here. It's 6 by 9, about 96 pages, and it is essentially a fundraiser for Would-Be Audubon Society and a other nonprofit organization we have on Would-Be called Little Big Fest, which is more the music and arts. And we will be having a book launch, as you can see on this poster, on October 26th at the Ottenhunter Winery in Langley, which is a Sunday from 3 to 5 p.m. We are looking at having a stack of books for sale for $12.99. And that means $5 goes to the birds and $5 to Little Big Fest. So it's a nice bang for your buck. Conservation dollars at work here. And out of that $5 for Would-Be Audubon Society, it's split in half to $2.50 of it goes to the Salish Sea Guillemot Network. And then the other $2.50 general fund for Would-Be Audubon. So basically it's a combination of me drawing 40 Washington state birds, and we've paired them with 40 songs of the Grateful Dead. So you may think that there is no correlation and connection, but once you buy the book, you will see that there actually is quite a crossover between deadheads and birders. So you say, come one, come all. If you're a birder, great. If you're a deadhead, great. If you're neither or both, it'll be good fun. We'll have a set list for everyone to take home. Well, of course, we wanted 40 songs on these CDs, but that would be way too many CDs. So we did our top 10. So that can come home with you that day. And also Would-Be Audubon is going to have a few birds on display, including a pigeon guillemot and some corvids of our specimen library. So hope to see you all there. And if you cannot make it to the book launch, we will have the books available online through Ingram Spark in November. And hope to see you on the 26th. Thanks.
Awesome. Thank you so much, Govinda. That really looks like a fun book, and I can't wait to get my hands on it. So thank you so much for introducing that to us. All right, I'm going to stop sharing. I just want to thank everyone for sending in your photos. I always enjoy getting photos throughout the season, and I think it really helps connect us as a group so that we can see what's happening outside our region and within the larger the greater Salish Sea. And I especially wanted to see what some of the different bluffs looked like, because I know there are differences from region to region. And so you'll see that there are bluff pictures scattered throughout this video that I created for this season's event. So I'm going to share that now, and I hope that you enjoy. Okay, here it comes. Oops. There again. All right, so hopefully you guys enjoyed that, and hopefully next year I will get any of the bluffs or colonies that I wasn't able to get in this year. So it would be fun to have everyone represented and to be able to see that. Oh, thank you for the hearts. I like that. All right, so I know everyone's been waiting for the data presentation, me included. And I know many of you are familiar with Dave Kraus, but some of you may not know who Dave is. He's a volunteer and surveyor as part of the Whidbey Island Survey Region. And Dave really knows our data systems backwards and forwards, and he's spent countless hours tracking our data, cleaning it up, advising us on protocols and data collection, and of course, providing us with our wonderful end of season data summaries every year. Dave really is a rock star, and we would be lost without him. We're so fortunate to have Dave on our team. So with that, I'm going to hand this over to Dave for our 2025 data summary. Go for it, Dave.
I'm trying to go for it. Yeah, hello everybody. Shannon, that was really a nice program you put together.
Oh, thank you. It's always fun.
There we go. Okay. Yeah, and thank you everybody on the survey who has done such a great job this year and past years putting the data together. We now have a data set from 2021 to 2025 that's under the that has been the surveys have been performed and the data has been put into the Washington Department of Fish and Wildlife system. And that is our cleanest data. And that's what pretty much I'll be showing tonight. I assume you can see the first page of this.
We can. Looks good.
Thank you. So you all who do the survey know this like the back of your hands. The data we collect, Pigu population counts, we log visits to burrows with no prey, we log prey deliveries, and we do our best to identify what type of prey is being delivered. We record disturbances and tide information, and hopefully we make notes about weather conditions that make it difficult for you to count Pigu or to see deliveries. These are a few, the main people who use our data, and it's really great that Sarah is here tonight to talk about what the University of Washington is doing right now. There's the volunteer data from 2025 this year. We were 7 regions this year, covering 8 counties, maybe 9. I'm not sure I have my geography right with South Sound. We had 243 beach volunteers. 65 colonies were surveyed, which is that's about average for us. 765 surveys performed and nearly 5,300 volunteer hours. So those numbers are pretty staggering, really. Can you imagine paying for such a survey? This chart on the right here shows the number of surveys per week that we did. So we were around probably averaging about 60 during the heart of the season. I want to cover just a couple of definitions here before we dive into the data. So it'll hopefully make the data more understandable. We identify the Pigu population as the sum of the maximum PG count at each colony for each region over the length of the season. So it's not a single day count that establishes the population. It can be different colonies have different maximums on different survey weeks, but we sum all of those up, and that's how we arrive at the Pigu population. An active burrow is a burrow that we've seen a PG entering with or without prey. And when we talk about the data, we consider that an attempt to breed. It's very difficult sometimes to tell whether a PG is actually entering a burrow. So this is a tough data point. The percent attempting to breed is 2, which are the parents or hopeful parents, times the number of active burrows divided by the Pigu population. A chick burrow, of course, is a burrow into which a Pigu has delivered prey. And when we talk about breeding in the data, we're talking about successful breeding, which means prey has been delivered to a burrow. Percent successfully breeding are the 2 parents times the number of chick burrows we've identified divided by the Pigu population. And the last one here, reproductive success. We don't have any definite markers for what allows fledging to occur, but one that we can use is how many weeks there are between the first and the last delivery to a burrow. And later on in this data, you'll see that we use 4 weeks as a marker. 4 weeks between surveys, or 4 weeks between first and last, which is 28 days. And we assume there is some probably time on the front end of that and on the back end, because we're only sampling. We don't really know what is happening. Here's a snapshot of the PG data for the season. The population we had was 2,149 birds, and some of the calcs are done with only 1,977 birds, because some colonies we have, we don't monitor burrows because they're too difficult to identify where they are. So we count the PGs there, and we also count the deliveries and the delivery type of prey. 521 active burrows, 300 chick burrows, and we saw 1,338 prey delivered. I'd like to see those all in a pile just to get a sense of what that looks like. But it's a pretty good number of little fish and an occasional shrimp and crab. The circle over here shows kind of the relative sizes of the populations at the different regions. And it's not really the populations at the regions, because again, we are sampling. So it has a lot to do with the number of colonies that you are surveying. But a lot of the numbers, because Whidbey is so large and has so many colonies, a lot of the numbers are kind of skewed by the Whidbey data. So in this presentation, what I've done is scaled a lot of the numbers into percents, so that each region is represented by a percent, which kind of levels out all of the data. Here's the PG population over 2021 through 2025. And you can see it's relatively steady. We tend to monitor about the same number of colonies each year. So you would hope that the population would be steady, or at least not declining. But this doesn't mean that the population is climbing. It just might mean that we are surveying more colonies. And in 2022, we inducted Jefferson County East into our survey, so their data has been added from 2022 on. these are a couple of charts you've probably all seen before. This is this chart on the left is again from 2021 to 2025, and it shows on the bottom line here, it shows the percentage of the Pigu population that is breeding, which means they've actually have chick burrows. And above that is the percentage of the population that has attempted to breed. So that's based on the active burrows that have been identified. And basically over time, this about 30% of the PG population successfully breeding, producing chicks. That's been a pretty good number. It's up a little bit from some prior years, but pretty much around 30%. And this attempting to breed number is usually around 50%. On the right here, we see the breeding percentages by region, and there are compared to 2025 compared to the last 4 years, the previous 4 years. And this year, it's about, probably a lot like usual, like other years. You see the SSGN over on the right here. So overall, we're about where we normally are in the successful breeding category, around 30%. So one of the things we always wonder about is how many chicks are being produced. We don't have any good way of knowing that. The University of Washington is visiting how to tease out what's really happening with the population, and that data is really important to knowing whether there is a declining population, a steady population, or an increasing population, and our data is helping with that analysis. So, but one thing we can look at are the number of weeks between the first and last prey deliveries. Presumably, if you only saw one prey delivery to a burrow in a season, you would think, well, not very likely that was producing fledglings. But if you saw a delivery 1 week and maybe the next week and maybe not the next 2 weeks, but then again the following week, if you saw a number of deliveries over a number of weeks, that probably indicates a very higher percentage or likelihood that burrow produced fledglings. So this chart on the left here is a comparison between the percent of chick burrows that had down here, the indicated at the bottom, the indicated number of weeks between the first and last observation. And this number is pretty high. This means where you have 0, it means for those chick burrows, which is for 2025 is 34% of 300 chick burrows. Those had a single delivery. It was never seen again during the season to have a delivery. So probably strong likelihood that those burrows were not producing fledglings. But as you increase the number of weeks that you've seen deliveries or between the first and last delivery, you start beginning to think, yeah, there's a good chance. And you've all this season, I'm sure you've all seen burrows where the fish keep getting bigger, and week after week they're delivered, and finally there are no more deliveries. Well, you kind of suspect that the fledgling dropped out of that burrow and made it to the water, and we start seeing the fledglings later in the season. So as we're out here with maybe 4 weeks between first and last delivery, or 5 weeks between the first and last delivery, or even more, that's probably good territory for reproduction of the species. The right-hand side is just the same 2020 chart here, but with the actual numbers of burrows for each category. 2025. And this is the same information, but shown for each of our regions. And Dashon is breaks the bank on this one. But it's because they had it was a single burrow that that did exceed 4 weeks between the first and last delivery. Kitsap had a really successful breeding season. The rest of us kind of normal, you know, down for 4 or more weeks between the first and last delivery, down around 20-25% generally. And the overall, the average over the 5 years for the SSGN is just over 25%, about 26%. So this year we're at about 22% in this category. So another indicator of how well the season is going for the Pigu might be provisioning of chick burrows. And that's why it's so important that we're doing what we're doing. We get that information. So on the left-hand side here, 2021 to 2025, they're all, you know, 4.1 to 4.4 chicks delivered per chicks. That would be wonderful. Fish delivered per chick burrow. So that's a pretty steady number. Our data goes back well farther than this, and these numbers are pretty consistent. A little drop the last 2 years over 2023, but I would say that's probably not significant, but something we would want to monitor in succeeding years. And on the right-hand side, the distribution of deliveries to burrows. This is the percent of chick burrows. The vertical is percent of chick burrows that received the indicated number of prey delivered in a season. So for this year, we were just, if you look at the first blue bar, we were just under 40% of chick burrows that received only 1 or 2 deliveries during the season. And this is also a likely indicator of the burrow success. As you move down this chart, you know, we get into 3 or 4 deliveries per season, 5 and 6, 7 and 8, and on and on. And, you know, as you get out here, that's a lot of deliveries, probably a lot of weeks. Probably a greater success that we're getting fledglings. And of course, we monitor the type of prey. In 2025, the Pigu delivered 821 gunnel, 392 sculpin, and 133 other. And so 2021 through 2025, you can see pretty steady percentages of each. Usually a little bit over 60% of gunnels, and 30%, a little less than 30% of sculpin, and about 10% of other. And with respect to each region, this is 2025 compared to it is 2025, excuse me. So the blue is the gunnel, the orange is sculpin, and gray is other. And this year is a little different than normal. these colonies, Camino, Clallam, Jefferson, and Kitsap, usually have a very high percentage of gunnel, and they did again this year. South Sound, though, had a higher percentage of sculpin than normal. So that's interesting, and it'll be interesting to see what happens next year with them. But Vashon and Whidbey are about as we always are, and Whidbey sometimes, occasionally, has had more sculpin delivered than gunnel. Usually it's a little bit more gunnel. And the primary gunnel majority colonies on Whidbey are all on the west side of the island. And I know there's a little study there waiting to be undertaken to figure out why that is. This is the time distribution of prey deliveries. So each marker is the percent of the total amount of prey that was delivered during the season during that particular survey. So if we're looking at the 2022 through 2024 data, which is the blue line, if we look at this peak here, the 723 week of surveys, we see that we're at about 17% of the total number of prey that were delivered during those seasons were delivered. 17% were delivered during that week. And these curves are really, really steady. If you put all the years over one another, you get a very nice curve like this. Usually a little slopier on the earlier stage and a little more steep on the back end. And so at Whidbey, and I don't know about the other colonies, but we felt that we had a slower starting season this year than normal. And this curve would agree with that. That historically, during the preceding 4 years, we had more deliveries earlier than we did this year because the orange line is underneath the blue line in this area. And we have differences between regions as well. I took a look at, when do the different regions hit their peak, and it looks like South Sound hits their peak probably nearly 2 weeks ahead of when Whidbey and Clallam and Jefferson hit theirs. I'll take a deeper look at that eventually, but it's interesting. It does seem that the northern colonies or more inland colonies have earlier peaks, which you might think would be due to some kind of temperature component, but there's more to be done there. We also monitor disturbances, and this circle on the pie chart on the right shows that eagles predominate in our disturbances. And this is 2025, and I looked at the 2024 data, and it was also 41% of disturbances were eagles. And if you compare the left chart to the right chart, which shows the percent of disturbance duration for the entire season for the total SSGN, you see that eagles accounted for over half of the total upset time for the pigeon guillemots. So eagles are the highest causation of disturbances, and their disturbances have the greatest impact. It is nice seeing them, though. It's just a plug for all of us who would wish they would fly away as soon as we get there. And then you've all felt this, I'm sure, how quickly the season ends. Everything is going along great. And then all of a sudden, everybody leaves town. And this chart shows the counts for each week, population counts for each week of the season. And then in about mid-August, everybody leaves and we start thinking about how much fun the season has been and how disappointing it is that we may only have 2 surveys left, which are really fun surveys, by the way, but it's also really fun watching the Pigeon. Just a few quick hits for the season. The first observed delivery was June 2nd, and that was at Jefferson East at Snake Rock Estates. And I'm sure curious about the name of that place. The last observed delivery was September 8th at Whidbey Keystone Borough P1. And the most weeks between the first and last delivery to a borough was 10 at Whidbey Double Bluff. And obviously something's happening there. They did not kick out the teenager. Or maybe it's multiple families, or maybe another breeding attempt. You know, who knows what happened there, but 10 is more than is needed. Most deliveries to a borough in a single survey was 9 at Whidbey Lake Hancock North. And I'm excited to see a borough get 3 deliveries in a survey. I can't even imagine how much fun 9 must have been and how crazy it was as well. Most deliveries to a borough during the season, 17. Whidbey Keystone Borough J2, that is a borough that's in the Jetty Rocks, right where the Port Townsend to Keystone Ferry comes in. And the most weeks surveyed, 17, South Sound Big Fish Trap and Whidbey Keystone. And that's a third of a year. I know we talk about 10 weeks minimum. That's just to get you interested in the surveying. And that's it. Thank you.
Thank you so much, Dave. That was wonderful. And it's so neat to finally see the graphs and see the numbers on the page. We always have these questions and, you know, like you said, wondering about if the season was slow to start. So it's really great to be able to see that. I did see one question here. Hal asked, how do you count a situation where we had three Pigeon delivered fish within a minute? And I'm not sure which part of the presentation that referred to, but
the question, let me look at it here. How do you account for the situation where you have three fish delivered to the same borough?
Right. You delivered fish within 1 minute.
How do we account for that? I mean, I don't think we really know, but we sure do suspect that there are 2 mating pairs in there, but we don't count it as 2 mating pairs. And I don't know, that's certainly worth having a discussion about.
Yeah, I think we've seen a few boroughs where we've suspected it could be a 2-bedroom condo because of the activity. So
yeah,
I think it's possible.
yeah, I'm sure our numbers underpredict the number of chick boroughs.
All right, well, thank you so much. And thank you too to everyone for submitting your data on time this season. I think this is probably the best season ever for data entry, and it just really makes everything so much easier. We can get it checked and get the summary done. So thank you to all the volunteers as well.
I second.
All right, well, it looks like we're right on schedule here to go into our guest speaker presentations. I'm really happy to introduce you to our 2 guest speakers this evening. We have Erin Arzola-Davis with us, who's a student at the University of Washington Environmental Science and Resource Management program, and she'll be graduating in December. And the work she's presenting this evening was done as part of her undergraduate capstone. And I've also been very fortunate to work with Erin myself down here in the South Sound. She was a summer intern with Terrence Lee through the Nisqually Reach Nature Center. And so she helped coordinate pig use surveys on Anderson Island for 2 seasons. So I'm really excited to see her here this evening. And Dr. Sarah Converse has been mentoring Erin on her capstone and is also a longtime champion of our program and of the Guillemots, completing research on Salish sea guillemots using both our data and also her own, through her own research projects. And she has also spent much time mentoring us and helping us dial in our protocols. Sarah is a professor at the University of Washington, and she leads the Quantitative Conservation Lab, where she works with students to develop models to better understand wildlife population dynamics and inform and improve their management. And as part of her work, she's been conducting research on pigeon guillemots on Protection Island. So she will talk to us a little bit about that this evening. So I will hand it over to you, Erin and Sarah.
Thank you, Shannon. And I can't start without just taking a moment to acknowledge Dave and Shannon and all they do for this project. They are absolutely both worth their weight in gold to this program. So it's always such a delight to see how amazingly professional you do with all this data. So thanks for that, and thanks for inviting me to be here. Dave really so nicely teed up what Erin is going to talk about, which is really exciting. So what I'll do is share a presentation. Hopefully this looks okay to folks.
Looks great.
Great. So yeah, we thought we would sort of do this tag team style. So we really kind of want to talk about a little bit of a mix of projects where sort of underneath all of them, we're really just trying to understand the relationship between pigeon guillemots and their habitat, which is, as we all know, changing. And so we'll talk a little bit about that today. And so kind of big picture, we're going to talk about sort of what we're trying to do with pigeon guillemots in the Salish Sea. Erin's going to talk about her work. And then I'm going to talk a little bit about Protection Island. I've talked to this group, I think, before about Protection Island, but maybe it's been a few years. So I'll provide some more updated info. And then I'll just finish up a little bit with some of the work to come. So just sort of big picture, I just wanted to talk about what we're trying to learn and why. So the first thing that you all know are that pigeon guillemots have been identified as an indicator species for Puget Sound. So the Puget Sound Partnership has identified them as an indicator species, what they call a vital sign. And because of that, it's really key that we really understand their relationship with their habitat so that we can understand the signals that we're getting from monitoring. What are pigeon guillemots telling us about what's happening in the marine environment and in the terrestrial environment in Puget Sound and in the larger Salish Sea? Another really important point about pigeon guillemots is, I mean, one, we're, I think, just so amazingly fortunate here that we have several alcids that breed near us here. That's not something that lots of people have access to, but we have several alcids that breed right here in the Salish Sea, which is cool. And some of those species are not doing as well as pigeon guillemots. We know that in general, the alcids are sensitive to a variety of threats, including climate change and human disturbance. So better understanding these threats will help us to conserve pigeon guillemots. And it may tell us some things that would help us to conserve other alcids in this region. And then last, and perhaps most important, is they're just fascinating birds, and better understanding their ecology enriches our lives and our understanding of this amazing place that we all call home. So those are kind of our motivations for this work. And with that, I'm gonna step back a minute and let Erin tell you about what she's been doing for her senior thesis. And Erin, you just let me know when you want me to forward your slides.
Awesome, will do. Can you hear me okay?
You can.
Okay, perfect. Thank you so much, Shannon and David and Dr. Converse, for all that you're doing this this presentation and celebration. This is my first celebration I think that I've been to. So yeah, super excited to be here. All right. If you want to go to the next slide. So Shannon already introduced me, but my name is Erin Arzola-Davis, and I'm an undergraduate studying environmental science and resource management with a focus on wildlife conservation at the University of Washington, doing a minor in marine biology. And I was a summer intern. I'm originally from Anderson Island, so I interned with the Nisqually Reach during the summers of 2023 and 2024, which is actually not where I was first introduced to the SSGN program. I was first introduced as a kid at summer camp that the Reach did that summer. So yeah, I've been watching the guillemots on the beach for many, many years, whether or not I had a data sheet in my hand. And so yeah, I had to do this capstone project as part of my graduation requirement in the School of Environmental and Forest Sciences. And I was super excited to learn that Dr. Converse was at UW and that she's involved in this program, especially because of how much data there is. Not a lot of people at a lot of seniors in my major get to work with such a like heavy data set. So that was an awesome opportunity. Just I'm also really happy that I was able to be involved in the collection of this data. So it really just brings this whole full circle moment where I'm able to produce something tangible from those many early mornings that I spent on the beach. And I'm ready for the next slide. So just to kind of reiterate what we already know about the birds and kind of set the stage for the research questions that I wanted to do. I really wanted to focus on the phenology of the birds, which is the timing of their life history events, particularly reproduction is what we're looking at since they breed here in the Puget Sound. We know that that timing affects their fitness. You need to maximize the resources that they have when they have it, because reproduction is very energetically costly. And we also know that some birds exhibit plasticity in their phenology. We know that climate change is a big driver of this change in breeding phenology, especially in polar seas. We see there's a lot of publications about that. And like Sarah already mentioned, we know that the guillemots are an indicator species here in the Puget Sound. So what I want to do for my study is I wanted to describe spatial and temporal patterns of their phenology in the Puget Sound. And I wanted to identify the scale of the drivers to see if it was maybe local or global drivers. And I'm ready for the next slide. So you guys already know all about the beach protocol, so I won't go over that. But basically, I took the big data set from, I think it was 14 years of data, 14 year data series, and I identified the highest count from each colony and year combination, and I used that to kind of identify when peak breeding season is. We talk about that a lot when we're trying to get enough people on the beach. Oh, it's peak. Need more volunteers this week. So I quantified that and used that week of year number as my main response variable. And I made a bunch of models to examine the influence of latitude, year, and sea surface temperature on that week of the peak count to see when how those drivers might be affecting the timing of the breeding. And I use the count data particularly because it has the least amount of noise, as we say, when we're doing statistics. It's more or less pretty clear cut when we're doing the counts on the beach. So that we determined that would be the most reliable data to work with. I'm ready for the next slide. From a statistical standpoint, we found my top model was one that included both latitude and the survey year as the main drivers of changes in phenology. So we found a positive effect of latitude, meaning that the higher we went up north, the peaks were later in the year over those many years. And then we also found a negative effect of year. So as time went on, the peaks occurred earlier in the year. And I'm ready for the next slide. And we can see this modeled in these graphs these are estimates from that top model. We see that for latitude, for every 1 degree north, peak breeding occurred an estimated, I have it right here, estimated 0.86 weeks later. So over that latitude and a half, that was over an entire week's difference in peak between South Sound and the northernmost regions. This is a small effect that we found, but we would expect it to be a small effect considering that the range is so small that we're looking at. And that was also kind of gratifying since the South Sound protocols actually have us starting a week earlier, I think, than a lot of the other regions. So I thought that was cool. We also see in the bottom graph that stronger negative relationship. My model predicted that peak breeding occurred an estimated quarter of a week earlier every year. So over 14 years, that was an estimated shift of about 3.5 weeks. And then over on the right on this bottom graph, where those dashed lines are, those were oh, I guess it's not on this graph, but we had some future predictions showing years 2025 to 2027, but it probably in actuality wouldn't be quite such a linear relationship. We'd probably see it end up like evening out at the bottom, more of an upside down curve rather than completely linear. That's what we might predict to see in the future. There's probably some limit to how earlier their phenology will shift, that is to say. And I'm ready for the next slide. Just to reiterate the main points concerning this short exploratory study, the Puget Sound pig ewes have experienced a shift in their phenology over time, a forward shift to occur earlier. They have exhibited a latitudinal gradient in their phenology, where the northernmost ones are breeding a little bit later than the southern pig ewes. And this study also adds to existing global evidence of the flexibility of the seabirds' phenology, especially in mid-latitude regions. A lot of the publications focus on those polar regions in the north and south, and there's not a lot of publications concerning these middle of the road seabirds. And this also adds to existing global evidence that seabirds are adjusting their breeding to occur earlier in the year. So if you remember from my research question slide, one of the goals I wanted to do was look at the scale of these drivers, which is hard to do just in this short project that I did. But the apparent local driver, which we found to be latitude, I think it would be interesting to look at that in the larger context of the Pigu's range, specifically up in BC, or even looking on, the other side of the Pacific Ocean to see what's going on over there, if that gradient is present or not. And then it could be important in the future to examine those larger scale mechanisms that is causing the guillemots to return to their breeding habitats earlier over time. And I think that is the end of my presentation. Thank you.
Thanks, Erin. I can keep going, and then maybe we can have time at the end and talk about all of it, if that sounds good.
Sounds
Yeah,
good.
I'm glad you got to hear about this work. This was really fun, and it's really fun to be able to use this big data set. I'm going to now sort of shift gears a little bit and talk about a different place and a data set that exists at a much different, much smaller scale. And this is a work we've been doing at Protection Island. And this work has all sort of been focused on understanding threats to foraging habitat in the Salish Sea, as well as how those threats might be affecting the population. And this has been a pretty big project, lots of collaborators on this, lots of funders. So the folks here at UW who worked on this, Liam Pendleton, who was a former graduate student, Alex Conan, who was an undergraduate who was also a technician on the project, Eric Wagner, who's a research scientist in biology, and Matt Farr, who's a postdoc in my lab. So our big kind of collaborators on this, Scott Pearson from WDFW. Many of you have kind of come across Scott or heard from him on calls like this before. Sue Thomas, who is now retired, but formerly Fish and Wildlife Service Protection Island and the Washington Maritime Refuges biologist. Another retired biologist, Lee Robinson, who did the original work on Protection Island that I'll mention. And a lot of other people who have really contributed to this work. And also I want to acknowledge a lot of organizations that provided funding, the CDOC Society, the Fish and Wildlife Service Pacific Birds Program, and the Coastal Program for Region 1, which is the Pacific region, the Science Support Program in USGS, the American Wildlife Conservation Foundation, Wilson Ornithological Society, and the School of Aquatic and Fishery Sciences at the University of Washington, as well as in-kind support from WDFW, Fish and Wildlife Service, and the Washington Co-op Unit, which is the organization I head at University of Washington. Okay, so this is Protection Island. This is going to look pretty familiar to those of you who are in Jefferson or Clallam County. Basically, this Protection Island is in Jefferson County. This is the Quimper Peninsula. Port Townsend's right here. This is the Miller Peninsula. This is Clallam County, as is this. Clallam County and Sequim is here. Everyone, I think, probably recognizes Dungeness, but so just this little place right here. It's a protected island and really has largely been protected because it is so important to seabirds. There are an estimated 1,200 odd guillemots that nest on the cliffs and in the shoreline debris, woody debris. This is a really critical island for rhinoceros auklets, largest nesting site in the Salish Sea, about 36,000 pairs estimated. There are large numbers of pelagic cormorants and Olympic gulls, and there are also small numbers of black oyster catchers, and unfortunately very small at this point numbers of tufted puffins, really just less than a handful tufted puffins that are now to be found at Protection Island. This is just a nice photo from the area. You can see we come kind of from the south usually. Sometimes we come from the east, and we typically come in here to this little marina right here. And as you come into this marina early on a summer morning, all you can hear is gull calls and guillemot whistles, and it is a really cool cool place to be. Other sort of neat things about this spit over here is a pupping area for harbor seals. We also see elephant seals hauled out there pretty regularly. It's a pretty cool place. And then here's just another look that you can get at it from one angle, where you can actually see kind of the variety of habitat. This kind of habitat here, this is rhinoceros auklet habitat. This habitat over here, this is guillemot habitat. This is, or was at one time, puffin habitat. And then along the shore, you get this woody debris, and the guillemots also really like this habitat. And then just another view. So now here we're looking back towards Sequim. And of course, as I mentioned, it's a protected area. Most of it is owned by the Fish and Wildlife Service. It's now actually managed by Jamestown S'Klallam tribe as of this year, which is really interesting, and they've already been good partners. So I'm excited to be able to potentially work with them more in the future. And then part of the island is also owned by the Washington Department of Fish and Wildlife. So we're really trying, at least today, I'm going to talk about two things that we've been trying to do. First is understand a relationship between foraging conditions and demography. I'm going to really, in particular, focus today on breeding success, although we're also working on survival. And identifying specific critical foraging sites used by pigeon guillemots at Protection Island, and determine the characteristics of that foraging habitat. So I'll talk about the first one first, really focusing on this question about how do oceanographic conditions, how do those marine conditions influence the breeding success of guillemots? And so just a couple of photos here. Obviously, we are banding the guillemots. So you can see here a combination of a metal, USGS metal band, as well as these colored bands that are in combination. So if we can recite them sitting on the beach, we can get recites without recapturing them. This is a guillemot egg. Many of you will know what this looks like. These are some of the nest boxes that we use. These are sort of portable nest boxes that we put out every year. There are also 13, or actually 12 now, permanent nest boxes that are actually dug into the ground in the marina. And then here we're doing some measurements on an adult. So we have these permanent nest boxes, and then we also put these temporary portable nest boxes out in the woody debris along the shoreline. And these birds take to these boxes pretty readily. And so once we put them out early in the season before the birds want to start setting up shop. And then we monitor them weekly from pre-laying through fledging. We also, I mentioned that one of our collaborators is Lee Robinson, a Fish and Wildlife Service retiree. She worked and did this kind of work actually for 18 years at Protection Island, which is amazing, and has given us access to her data set. And then she monitored 410 nests and banded 564 chicks during that time. And then we have since added 3 years, 2022, 2023, and 2024, where we've monitored 17, 23, and 23 nests, and we've banded 8 through 13 and 18 chicks in those years. So, sort of getting into how do we link nesting success to outcomes? So typically what we would do is when we make that first nest check in early June, late May, we're going to see often something like this in a nest box. This is one of the boxes that's actually dug into the ground in the marina. You take the lid off of it, and there's a couple of Guillemot eggs. And often if there's a couple of Guillemot eggs, there's also an adult in the nest. At some point, those Guillemots hatch out, and we've got chicks in the box. The chicks go from nice and pretty and black and clean when they're young until just before fledging, when they are in need of a bath. So fledging is good for them. They get to go out and have a bath. And so then at some point we keep coming back and the box is empty. And so then what we do is we say if the minimum age of the birds is at least 29 days, we assume that those chicks fledged. And we record outcomes of 0, 1, or 2. And I'll tell you what these mean in a minute. So 0 is we expect that no birds fledged. 1 is 1 bird fledged, and 2 is 2 birds fledged from that nest. And then we model these with these, scientists can't help but use Greek symbols. So we model these with these probabilities. So B is the probability of producing at least 1 chick. So if we get no production, then we have that probability is 1 minus B, the probability of getting at least 1 chick. We can also get just 1 chick produced. So yes, we got 1 chick, so with probability phi, but we did not get a second chick, and we give that a probability psi, and so we did not get that, gamma, so we did not get that second chick. And then we also have this happy outcome where we got our first chick and we got our second chick. So you can think of this as, with people, right? This is the women who don't have any children. This is the women who have a single child, and this is the women who have multiple children, right? Multiple births. And so we're doing basically the same thing with our Guillemots. And then we're modeling each of these probabilities as a function of oceanographic conditions in a given year. And we looked at 4 different oceanographic indicators, 2 of which are local and 2 of which are large scale. So we looked at chlorophyll, which is a local predictor of productivity, as well as the North Pacific gyre oscillation, another predictor at a much larger scale of ocean productivity. Another local predictor is sea surface temperature, and the Pacific decadal oscillation. So these are the hypotheses we had about what we expected in terms of our breeding success and possibly our sort of twinning probability, the relationship that we expected to see with these marine indices. And so we, as Erin talked about, we fit these models and we assess sort of the strength of evidence for the models in the data. And we fit a lot of models, and what I'm showing you here are really the only 2 models that had sort of a meaningful amount of support. So we talk about the weight of the models within the whole data set. So these 2 models accounted for 40% of the weight, and then all the other models we ran accounted for 5% or less of the weight. So we think that these are the most supported models. And the big picture thing here is they're pretty simple models. So we put year in every model. We basically allow for this residual annual variation. And so that sort of kind of cleans up what's left after we bring in these covariates. And the only covariate we found support for was the North Pacific gyre oscillation. And we saw that this had some impact on the probability of nest success, the probability of producing at least 1 chick, although it wasn't hugely more supported than a model that had no effect. So in essence, what we found was that there is annual variation, but we couldn't really tie it strongly to any of these oceanographic indices. This is what sort of our estimates for these different probabilities looks like. So this is the probability of having at least 1 chick. So this is sort of equivalent of that sort of, nest success that Dave talked a little bit about. And when we get in and we monitor them every week and we see what's going on, what we get at Protection Island is about 62 60% or so of the nests produced, that the nests that are defined by a place, you know, a nest that had an egg or 1 or 2 eggs in it at some point, that's the probability that those nests produce at least 1 chick, 1 fledged chick, I should say. And then this is the probability that, given you fledged at least 1 chick, the probability that you fledged 2, and that's about 25%. So what we're seeing at Protection Island is, so for those nests that are successful and fledge a chick, about 75% fledge 1 chick and about 25% fledge 2, even though the vast majority of those nests start with 2 eggs. And this is what the relationship with NPGO is. So this is sort of high NPGO years, low NPGO years, and we see this relationship. And again, NPGO, the North Pacific Gyre Oscillation, is an indicator of ocean productivity. So we do see this relationship with ocean productivity. And as I said, we also see this strong variability from year to year, especially in this nest success variable, much less in this twinning variable. That's pretty constant at around that 25% from year to year. So it might be that this sort of nesting success is, maybe this is more of an individual variation thing. Some guillemots are just experienced enough and good enough to be able to pull off those 2 chicks. And the sort of just the ability to pull off any chicks is really more tied to what's going on in the environment. So, you know, as I said, we found relatively little influence of these oceanographic indices on demography. Couple of points about that. We did look at a couple of Pacific-wide indices, and Protection Island, of course, being inside the Salish Sea, is somewhat sheltered from those. Although we do find in some other places, in some places like the Salish Sea, that those Pacific-wide processes can be important. And I think maybe in some ways more significantly, these guillemots are generalists. They really do, of all of our alcids here in Puget Sound, they do have a little bit more of a generalist capability and the sort of the potentially the ability to switch between prey types. Although it is interesting seeing how constant they've been in their preference for gunnel and sculpin over time. Okay, so that was sort of the first topic, and then the second topic is this work that we're doing on foraging habitat selection. So this right here that you can see, this is the back of a bird, and this is about a 4-gram tag that collects GPS points. And when the bird returns to the island, it transmits those GPS points to a base station that we put in the area. And we tape it onto the bird. It doesn't last very long, and it falls off because it is just on there with waterproof tape. But these birds seem to do really well with these, and they go out and they tell us where they're going. And so the goal here, as we said, is to understand what that important foraging habitat is. So we put these tags on 13 different guillemots. This work is also, we're doing this similar work with rhinoceros auklets at Protection Island, but I'm just talking here about the guillemots. And I'm not going to talk so much about the analysis right now. What we're doing is we're trying to fit what are known as resource selection functions so we can understand what they seem to be selecting for. But I thought what I would do here is just show you some maps of guillemot movement. I thought that might be most interesting. So again, this is Dungeness Spit, the Miller Peninsula, the Quimper Peninsula, Protection Island. So I'll just give you for scale, if you're not super familiar, sort of the tip of Dungeness Spit to Protection Island is about just a little under 9 miles. And so here you can see a guillemot moving around. I've got the dates at the top. This is over about a 4-day period, 3-day period. This guillemot moving around, staying pretty local. This is a very common thing that we see these guillemots moving over to the Miller Peninsula. And I'm interested to hear what Jefferson and Clallam County folks think about this with respect to the places that they're surveying. And a lot of this sort of foraging energy, probably foraging energy right offshore here. Another bird that stayed pretty close to home. This is clearly an errant location, don't believe that they're going that far inland. Another bird that's going over here closer to Dungeness Spit. We saw this pretty commonly, similar kind of thing here, birds that are moving over towards that direction, and similar kind of thing here. These birds are probably sitting and drifting on the current, which is why you probably get these kinds of patterns. So yeah, we're working on analyzing these data. As I said, bidding. First of all, what we're trying to do is understanding what of these points represent foraging, and we do that by fitting movement models that work to distinguish different kinds of behaviors. And so what we expect when birds are foraging is that they're moving kind of in tight clusters of points. And so we're looking for that kind of behavior. And then once we identify that foraging behavior, we can say, what is it about the places that they're foraging versus places where they could have foraged? And so this is sort of still ongoing work, publications to come. We're very close to submitting the Protection Island Nest Analysis. This is being led by Leanne Pendleton, a former master's student, as well as a postdoc in my lab, Matt Farr. The movement analysis that I've just been talking about, those same two folks are working on that. Erin talked about her work on phenology, which we would like to turn into a publication. And then some of you will remember a former PhD student of mine, Amanda Warlick. She's now a scientist with NOAA here in Seattle, working on marine mammals. And Amanda was working on, and Dave made reference to this, using the burrow visit data to understand nest productivity. And that is a publication that's just about ready to submit to a journal. And then I just wanted to mention a couple of new things. In addition to the potential to continue at Protection Island, a couple of weeks ago, I had a really nice opportunity to visit Jack Island and Bendovi Island. Some of you will know that Jack Island is just north of Guillemot Island, and Bendovi Island is a bit north of there. And these two islands are owned by the San Juan Preservation Trust. And so I've been in conversations with Kathleen Foley-Lewis, who works for the trust. And then we got to go out and visit with Kathleen and Thyatira Thompson, who is the caretaker of Bendovi Island and has really an amazing job to get to stay at Bendovi Island. And they are working on trying to do some restoration of some shoreline areas at Bendovi. So we would like to understand maybe what's going on there. And Jack Island is a pretty nice Guillemot nesting area. And so it offers up some opportunities to dig in and understand a little bit more of this ecology of Guillemots in the area. I'll also mention that there's a lot more to do with the Salish Sea Guillemot network data. I think we've only just scratched the surface. So yeah, thank you for letting me, rattle on quite a bit. I'll stop and open it up to questions, and including especially questions for Erin. Thank you so much.
Thank you so much, Erin and Sarah. That was really wonderful. And I just love that you guys have been digging into our data, getting in there and finding ways to analyze it, you know, more than just summarizing numbers, but actually looking at what's happening with the birds. And Erin, really well done. I was amazed at how significant the shift is in time, in a relatively short amount of time and over a relatively small area. So that's pretty incredible. Good job. Do we have any questions for Erin and Sarah? Dave, I see your hand.
Yeah, I have a question, and we've noticed at our colony that late in the season, we have juveniles that are fishing very close to the colony, just a little bit south and in the near shore. But the parents that are provisioning chicks seem to fly in from the west. And I've wondered why, why aren't they fishing the same young that that the juveniles are? Why are they expending so much energy flying away?
Yeah. So a couple of things I'll say. I mean, partly that's what we're trying to sort that out. Of course. Although what I will say is that one of the challenges of being a seabird ecologist is that the very thing that our study animals care most about is something that we can rarely see or get information on, right? So they are almost certainly what they care about is where are the fish? And so why are the fish consistently from year to year more likely to be seen off of the off of the mainland versus sort of right offshore from Protection Island? I don't think we totally know that, but we're certainly trying to dig into that and looking at things, looking at different predictors. We are also looking into potentially getting some data from forage fish surveys, but what we generally find is that the forage fish surveys are not as frequent or as regular as we would like them to be to really be able to dig into them and sort of hold them up against these long-term data sets. But yeah, it's probably some combination of depth and currents and other sources of nutrients that may be impacting where the forage fish are, and the birds are probably where the forage fish are. Yeah, it's a great question, though. It's really hard to know, and it's yeah, seabird biologists all over the world are constantly looking at these indicators that we know are kind of not the thing that our birds actually care about, but because we don't get to see what birds actually care about, we're looking for sort of things that might be correlated with them.
Thanks, Sarah.
Yeah.
Al, I see you've got your hand up.
We had observed at our beach that the species of fish delivered were almost burrow specific. I mean, in our area, it was almost all gunnels. If anybody brought in sculpins, it went to like a single burrow. So with these birds that you're tagging, are they coming back with a variety of fish, or are they targeting specific species more than others?
Yeah, that's a great question. I'm afraid we don't know that. I think probably, and I don't know that they've dug into this yet, although we are trying to find a way to work with folks in the Farallones who do have sort of long-term observations. And I think maybe you've even heard from Mike Johns on one of these calls, long-term observations of foraging. It would be really interesting to know. One of the things that fascinates me about animals is I think as people, we all recognize our individuality, but with the animals we study, we tend to say, oh, they do this or they do that. But there may be a lot of individual variation, and that individual variation may itself be a function of learning and experience, right? If I'm a Guillemot and I'm trying to carry off a nest, and I had good luck one year foraging in one area, I may go back to that area over and over again. We don't really have the kind of data that can help us figure that out, but we certainly see that in other species. And over time, we may be able to get the kind of data that might help us figure that out. It requires us to have, multiple year continuous data from individuals so that we can see, do we really see individuals doing different things? And it would be very interesting to have long-term data for individuals and see sort of how they build up their experience and their behaviors over time. that would be amazing, but isn't in our grasp yet with birds like this. But yeah, I think those are really interesting observations, and like I said, I'm very interested in the potential that those are sources of individual variation that may be learned. Yeah.
And Erin, Maria Ruth has a question for you. Can you confirm what I think you said, that the peak numbers of birds between 2012 and 2024 occurred 3.5 weeks earlier? And if so, do you think SSGN surveys should start earlier?
Yeah, Maria, thank you. They did occur, according to my model, about 3.5 weeks earlier. I think it was pretty close to what actually happened. If I'm remembering correctly, the peak in the earlier data, was happening around late July, early August, and in these most recent few years, peak has been occurring closer to the beginning of July. So I think maybe this survey's, I don't know if they're like arriving earlier. I know that every time for the 2 seasons that I surveyed, um, especially in 2023, there was already a lot of activity. So that might be an indication that we need to start the surveys earlier, but I don't want to make anyone groan at that advice.
Something to consider for sure. And I think
Yeah.
especially colonies who see that early activity, yeah, there's no reason why folks can't start earlier. So it's definitely something to think about.
Mhm.
Yeah, Francis, I see you've got your hand up as well.
Yeah, thanks. And Erin, thanks so much for that presentation. We've often found here on Whidbey Island that south-facing burrow colonies tend to start a little earlier as well. I don't know if that's something to consider for the future. And Sarah, it's really great to have you here again, and thank you so much for that presentation. My question really is, as I was listening to Dave's results, thank you, Dave, and also what you were saying about Protection Island, Sarah, it seems that the there is a higher success rate with the fledging chicks there on Protection Island,
Mm.
and the you have the opportunity of looking into the burrows and really figuring out what's going on there. So there's that going on. But is it your sense that that we're not catching that success rate to create it, to come up with it as high as yours is, or are there just too many other factors, disturbances, the fact that you're on an island without predators in the same sense that what we run into with our surveys?
Yeah, that's a great question. I was thinking about that when I was looking at Dave's numbers, and it is hard to disentangle these two things, right? Protection Island is a very different environment, but we're seeing success rates, in the 60+%. And so again, that's the probability of producing at least one chick. But I think that's probably pretty equivalent to what Dave was showing, and using the calculation method there, I think it was closer to, it's about 30 or something, wasn't it, Dave?
Yeah, so it was about, on average, about 25% of Whidbey, but around 30 at some other regions. Yes.
Yeah.
And we're
So-
not, I'm sorry, go ahead.
Oh, yeah. I mean, I'll just say, like, I think it could be both, either or both. But I will share that, yeah, what we do see is that those visits become fewer and farther between. It's harder to catch the adults sometimes, in the nest as those chicks are getting a bit older. And so, it might be that it's just harder to catch those late deliveries. what we haven't been able to spend enough time at the island for like long periods of time during the day to understand the shift in that delivery. But again, we do have the opportunity maybe to dig into looking at some of what they are learning in the Farallones, where they're able to observe these birds for long periods of time and get foraging information. This also offers up opportunities for places like, as I mentioned, like Jack Island. We could dig into some of these things potentially. Putting cameras on nest boxes offers all kinds of opportunities where we can actually know when adults are visiting. So my guess is that, I don't know, my guess is that your nesting success isn't that much lower, because if it was, like, it's hard for me to imagine that the birds would be as successful as they are there. And so that makes me think that it is probably, at least part of it is missing late and infrequent deliveries a little bit. And this was kind of one of the things that Amanda's trying to do with her modeling too, is sort of try to account for this and see if we can account for this sort of detection issue, which is such a big deal in wildlife studies. They don't want to be seen. We don't always see them. So we're trying to constantly sort of figure out how to account for that. Yeah, great question.
Yeah, thanks, Sarah.
Yeah.
It's tough. We can't just pop the lid off the top of the burrow
I
to see
know.
which burrows have eggs inside either. So our active burrows, which we're using as sort of a measure of breeding activity, we're not sure if they've laid eggs in all of those burrows or if they're just visiting. So yeah, that could skew it just a little bit as well. So all right, well, we've gone over time, but we really appreciate you staying on and answering a few questions. It's really fascinating information, and I'm happy that there's so much work being done with guillemots in the Salish Sea. And Erin, you mentioned Canada. It would be nice to add some of that data, and hopefully we'll be bringing BC into the survey. So within a few years, we could have some data coming out of the Northern Salish Sea as well. So it would be interesting to sort of run that analysis again and see how it's different.
Yeah, that would be awesome.
Yeah, thank you both so much for being here this evening and for giving us these wonderful presentations. We really appreciate it.
Thank you, and thanks to all of you for all your work. It's really fun to be able to benefit and play around with all the data you've worked so hard to collect.
Agreed. Thank you, guys.
Good to see you, Erin.
Good to see you guys.
And with that, we've come to the end of our evening. Thank you, everyone, for taking this time this evening, spending it with us. We had a wonderful season. It's so great to see everybody's faces and just to come together all at once here to celebrate our birds. I hope you all had a wonderful season and also enjoyed your time out on the beach, connecting with not just the guillemots, but all of the other wildlife and even the eagles and the seals, and just connecting with the Salish Sea. There's our Camino group there. Glad you guys are able to join us. Hope you had fun tonight. All right, well, thank you, everyone. Have a good evening. Take care, and hopefully we'll see you next season.